Introducing the SupelTox line of SPE products for sample cleanup prior to mycotoxin analysis. Mycotoxins are secondary metabolites produced by fungi. They elicit toxic effects in humans and livestock. They pose health risks of a weakened immune system, allergic reactions, cancer, or even death. As mycotoxin awareness and government regulations increase worldwide, allowable toxin levels continue to decrease. For quantitative mycotoxin analysis, HPLC and GC are among the most accurate and widely used techniques. The accuracy of the analysis method is highly dependent upon the removal of sample matrix interferences. Therefore, sample preparation is essential for quantitative mycotoxin analysis. Currently, those performing quantitative mycotoxin analysis use immunoaffinity columns, or IAC, for mycotoxin purification. However, there are a number of drawbacks associated with the immunoaffinity technique. Columns are often thermally unstable. The technique may introduce several sources of variability due to the complexity of the procedure. And immunoaffinity employs the bind and elute principle, which requires numerous steps. In the bind and elute strategy, after sample introduction, the mycotoxins become bound to the SPE sorbent. Next, the undesired matrix is washed from the cartridge. Finally, an elution solvent is used to elute the purified analyte. While immunoaffinity columns employ the bind and elute strategy, the SupelTox line of Aflazia, Dawn, and Trico cartridges utilize an interference removal principle. In this procedure, following sample introduction, the unwanted matrix components remain bound to the sorbent, while the purified analyte is eluted. The purification is accomplished in fewer steps, with better reproducibility and higher sample throughput. This study compared a leading brand of immunoaffinity columns to SupelTox Aflazia for the analysis of aflatoxins B1, B2, G1, and G2 in peanut paste. Sample processing time, product performance, and process simplicity were evaluated. A comparison of the two methods shows that the SPE technique using SupelTox Aflazia was 10 times faster than the immunoaffinity technique. In addition to time savings, the use of the SPE cartridges required fewer and less complicated steps, making the SPE cartridges more user-friendly than the immunoaffinity columns. The average percent recoveries and percent recovery values were compared for IAC and SPE purification techniques. The bar chart illustrates that SupelTox Aflazia SPE cartridges gave higher analyte recoveries of G2, G1, B2, and B1 than the IAC columns used in this study. Also, as shown by the error bars, the relative standard deviation was much smaller for the SupelTox SPE purification than for the IAC purification, indicating that the SPE cartridges also demonstrated better reproducibility in this experiment. A comparison of the chromatography illustrates that there was no significant difference in response or background when using the SPE method versus the IAC method. Therefore, the SPE method demonstrates sample cleanup performance equivalent to the IAC purification. In conclusion, this experiment supports the premise that SPE involves fewer steps than IAC, leading to time savings and increased throughput. SPE is less complicated than IAC, minimizing variation. And the performance of the SupelTox SPE cartridge is equal to or better than IAC. In terms of process simplicity, time required for sample preparation, and control of variation, the SupelTox Aflazia SPE cartridge demonstrates improvements over the immunoaffinity technique for the analysis of aflatoxins in peanut paste. Thank you for your interest in the SupelTox product line. For additional information, please visit sigma-aldrich.com/SupelTox. Request an evaluation sample. See the proof for yourself. To view our complete range of products for food analysis, visit sigma-aldrich.com/food.